Recall our 6 query operations: projection, selection, sorting, calculated fields, joins, and aggregation. We're going to do each of these now using structured query language. The traditional way to access a database server is using a console interface with just a flashing cursor and very little additional support. What we're going to do instead is use a very common web-based interface to the database server. So in this case, we're using PHP MyAdmin, and what it does is it provides a window that allows you to type in your SQL queries, but it also gives you some additional information about, say, the structure of your database. And of course, there's a results window and some additional functionality like an exporting tool. Structured query language is a relatively simple language. Recall that the basic syntax is a select statement followed by a list of columns from the table, and then the keyword from and the name of the table. So if we want to select certain fields from the customers table, we write select and rewrite all the names of the columns or fields, and then we put from customers, and to be 100% correct, we should finish the statement with a semicolon. To access the database server, I start by logging in to PHP MyAdmin, and I get a lot of information. All I have to do is remember that I want to go to the Northwind Traders database. And what that does is gives me a list of all my tables over on the left, and I can expand those, and I get a handy list of all the columns. Now, if I highlight the customers table, for example, and then go up and press SQL in the tab, I actually get the skeleton of a query. Select star, and remember star means all fields from customers where one. Now, two things to notice about this. Customers is put in the special quotation marks. This isn't a normal quotation mark. This is actually a special slanty quotation mark used to denote the name of something in the database environment. And then the where one just means, it just always evaluates to true, so I can delete that. So what I want to do here is type in the name of some fields. So I can go customer ID, column, or I can cheat and double click them over here and it types them in. And I can add some white space. That is, I can hit the return key if I want. So I can add city, and then I have to remember to add the comma, region, comma, and country to get the query I had originally. So select customer ID, company name, city, region, and country from customers, and you'll notice that when I built the query by double clicking over on the right, it added the special quotation marks, which is fine. Now I scroll down and hit go, and it will actually run the query. Remember that selection allows you to filter out certain rows from your result set. So here I've added a very simple where clause that says only give me the records, or the rows if you like, where the city equals London. Then I can make that more complicated by adding other logical operators like and, or not. So here the second query is where city equals London, or the country is Canada, but not from the region that equals Quebec. Say we have a query and we scroll down and we execute the query and I get a result set. Now, if I go back up and hit the SQL tab, I lose that query. So what I want to do instead is hit edit, and it gets me back to my original query. So for example, here I can add my conditions and then scroll down and hit go and verify that my results are correct. We seldom want to sort at this stage of the analytics process because we're just gathering data. But if we do want to sort in structured query language, we can simply add the order by clause followed by the name of the field or fields on which we want to sort. And then we can add a final keyword, either ascending or descending, to control the order of the sort. Writing a calculated field is very simple in structured query language. So here I have a normal select statement, and I start by projecting the field employee ID, which is just a normal field in the underlying table. And then I have a comma, and then I have an expression. We won't worry about this expression for a moment, but I have this big long expression. And then I have as full name. Now, full name is the new field name that I just made up. It's the field name of the calculated field. Now let's go back to this expression. The expression I've used in this case is a function that's built into MySQL called concat. And what that means is concatenation, or concatenate a whole bunch of strings. The first string is the field first name. So whatever's in the first name field is the first string. And then I have a comma, and then I have a literal string, simply a space. And then the last string is whatever it is that happens to be in the field last name. So the concat function here takes first name and then a space and then last name. Recall that the main advantage of the relational database model generally and normalized table design specifically is that everything's kept in one place. So we can keep information about orders in the orders table, and we can keep information about customers in the customers table. And then we rely on the query language to help us bring these things together. So here we have an orders table, and every order has exactly one customer. And we model that, or we represent that, by storing the customer ID as the foreign key in the orders table. So once I know the customer ID, the customer who placed the order, I can go over to the customers table and get that information. And that's what we're doing when we do a join. Now, the way we do this in structured query language is to change the from part of the query. So instead of saying from one table, we say from a join of multiple tables. And the specific type of join here is called an inner join. And we're not going to worry too much about this. But here I select from orders, inner join customers, and that puts the two tables together. Unfortunately, if you recall from the previous lesson, if you just join two tables without telling the query language what to join on, you get what's called the Cartesian join. It joins every order with every customer. That's not what we want. We want only the specific customer who placed the order. So we have to add another condition here. So here we use the on clause to say limit this join to those situations where the customer ID in the orders table is exactly equal to the customer ID in the customers table. It turns out that this query won't work because the field customer ID in the select statement is ambiguous. There's two customer ID fields, one in the orders table and one in the customers table. So what we could do is add the table name to every field to make sure that the query processor knows which table it comes from. But here we're going to use a trick called aliasing. So what I've done is I've added an alias, a short alias, to the from clause. So orders O and customers C. Now I can then go through all my fields in my query and use this shorthand to make the references unambiguous. Remember the point of aggregation. What we want to do is group records together according to some criterion. So for example, if we look at our orders table and we want to group all our orders together by customer ID, then we can do something like count the number of orders for each customer. So in this case, if I look at customer ID ALFKI, Alfred's Futterkist, and I group them together, I see that that customer has placed 6 orders. Now, to do this in structured query language, we use the group by operator. So what I do is I say group by customer ID, and then use some kind of aggregate function like count or sum to sort of take advantage of that grouping and give me an aggregate measure. Before I demonstrate aggregation, there's a couple things I want to point out about the PHP MyAdmin environment. The first is, if I want, I can get rid of this left sidebar by hiding the panel. The other thing I should point out is that there is a console button down at the bottom left, and if you click on it, you get access to all your old queries. So you have your history, and if you lose something, you can go back and get it. So I'm just going to get rid of that. And what I have here is a very simple aggregation query. If I scroll down and run it, I don't get quite what I want. I mean, I get the count of order ID, but it's not very attractive. So let's edit this and make it somewhat better. Because I'm grouping on customer ID, I can include customer ID in the output. That is, I don't have to group or aggregate that value. It'll just give me the customer ID for each group. The second thing is I might want to rename this function here, count, as something else. So I'm going to call it as num orders. That way, it's just a little bit easier to read. So if I run this now, I get the name of the customer, or the customer ID at least, and then num orders. And there's my 6. The last thing I might want to do here is include some ordering. So I can go order by, and here's the advantage of calling this thing num orders. I can refer to that alias now, num orders, and go in descending order. So when I run this now, what I really get here is a list of my customers sorted by the ones who place the most orders. Consider this query, which puts a few things together. First, I start by joining my orders table with the 2100 records in my orders detail table. The reason I do this is because when I know the order, then I know the customer. So what I do then is I group by customer ID. So every order from the same customer can now be treated together. I then calculate the amount of each order and sum that all up. So I get the total amount spent by every customer over every order. And finally, I sort that in decreasing order. So I get my best customers first. Let me now run this query and see what we get. So I click on Go, and the results don't look that good. And as you may have noticed, I only get a subset of the results. The web-based tool paginates my results so I don't crash my browser. What if I want to make this pretty or make it into a graph or something like that? I might want to export it into Excel. So what I do is I scroll down to the bottom, and sure enough, there is an export button. So I can click on export, and I can ignore the templates. The safest format is this CSV, comma, separated value. Now, I like to hit this custom button here, and I'll show you why. This allows me to go down to the bottom and put the column names in the first row. And that way, when you get your data, it's like a normal Excel spreadsheet with the column name in the first row. You don't have to try to remember what they were. I hit go, and it saves my Excel spreadsheet. And I can bring it over, and you see There I get my customer, and there I get my amount, and I can do other things with this now.